Okay, so center of gravity. Center of gravity for an object is a point on the object where the total weight of that object is felt. What is center of gravity? It's a point on an object where the total weight of the object is felt. At that point, the object can stay balanced. Okay, so to find the center of gravity, you just have to find the balance point where it balances. Now, for example, if I take this remote in my hand over here, okay, and I want to find where is the center of gravity, what I can do, I can just keep my finger and see where it is balancing. See, it's balancing over here. That means that is where the center of gravity. And at that center of gravity, the total weight of this remote will be at that point. If the remote is 100 grams, all that 100 grams will be felt at my fingertips. You
And
understand,
the
everyone?
equal distribution of the weights on either sides.
Yeah, not weights, but moments will be equal on both the sides. This chapter we're learning about moments, right? Moment is that rotational force. See, if there's a moment on this side, it'll cause the object to rotate in that direction. If there's more moment on the other side, it'll rotate in that direction. Okay. So instead of saying equal weight on both the sides, we should say what? Equal moments or equal moment of force on both the sides. Now, what if I move my balancing finger to one side? What's going to happen? It's going to fall off. Why? Because there is more dash on this side. What is that? More moment of force on this side. Okay. And is the total 100 grams falling on my fingers now? No. Right. Maybe only 30 grams or 40 grams is coming on my finger. The remaining is going on the other side. Okay. So 2 points about center of gravity. The first point is what? You can balance at that point. Second thing is the total weight of that object is felt at the center of gravity. Is that clear? Okay. So let's see if there's a definition for center of gravity. Yes, here. Let's read it together. The center of gravity of a body is the point about which the algebraic sum of moments of weights of all the particles constituting the body is zero. The entire weight, yeah, that's the first point. Second point is the entire weight of the body can be considered to act at this point, howsoever the body is placed. Okay. So what is the first point is the total moment of force will be zero. What do you mean zero? When we said zero, we didn't say zero. We said equal moments on both the sides. You can say either. You can say equal moments on both the sides, or you can say algebraic sum of all the moments will be zero. Why? So anti-clockwise moment of force was positive and clockwise moment was negative. Do you remember that from the first part? All anti-clockwise moment of force was considered as positive and clockwise moment of force was negative. So see, you have so many negatives and so many positives. If you add all of them, how much will you get? You'll get zero. That means that's the center of gravity, that point at which you're trying to balance. Okay, the algebraic sum will be zero. Yes, that's the first point. The second point is what? The entire weight of that object is felt at that center of gravity, however the body is placed. We didn't talk about that yet because it's not possible to show you. But what it means is, however you place this body, even if I hold this remote upside down, it will balance at that one point. Here it's not happening, it's falling off because the center of gravity for the remote is not outside, it is inside it. Okay. Center of gravity is a point inside the remote. At that point, however I place the remote, it will stay balanced at that point. Understand? Here, this is almost the center of gravity because it is balancing this way. But what happens the moment even if I or if I stick my finger to this using a glue. Now, what if I move it like this or like this? What's going to happen? It's going to fall off down here because I'm not exactly at the center of gravity. The center of gravity is inside the remote. Okay. For most of the objects, center of gravity is inside the object, right in the middle of the object. Okay. Here you have a list of different objects and where their center of gravity lies. Okay. So look at this. For a rod is like this. For the rod, where is the center of gravity? The midpoint of the rod. When we talk about rod, we're talking about a very thin rod. So we can just say the midpoint. Okay. But if it is a bigger object, like we'll see, circular disc. Circular disc means like a CD. For a CD, where is the center of gravity? Geometrical center. Find the center of that disc is there. Solid or a hollow sphere? Solid, anything big. Or a hollow sphere. Hollow sphere means it's empty inside. Where is the center of gravity? The geometrical center of that sphere. Is there any material inside that place? May not be. It's hollow. There is empty over there. But still, the geometric center can be. I mean, the center of gravity can be in an empty space in an object. It doesn't have to be on the mass somewhere. Okay. What if it's a okay? Okay. Let's see. Next, solid or a hollow cylinder. Okay, cylinder like this. A hollow cylinder. For this, where is the center of gravity again? Right in the middle. Yeah, so if you draw the axis is the line passing from the center till the center over here. The center of gravity will be in the midpoint of that axis, right? Midpoint on the axis of the cylinder. What about a cone? You all know what's a cone? Cone ice cream. Okay, a cone is like this. For a cone, where is the center of gravity? Ouch. If I take the cone sideways like this, okay, and then if I draw axis right through the center like this, okay, do you think the center of gravity will be in the midpoint of this axis? Why not? If I'm trying to balance it from the center, right from the center, will it stay balanced? No, which side will go down? The right side. The right side will go down, no, because you can see there's more weight on the right side. So the center of gravity will have to move to the left or to the right? To the right. If you want to balance it, you move it a little bit to the right. So say somewhere over here. Okay. Say at this point it'll balance. So you need to go more towards the heavier side. So they've come out with a calculation and they said that if it's a solid core, the center of gravity is at a height h divided by 4 from the base. If the whole height is 4 centimeters, you divide that 4 centimeter with 4 parts and one part of that. So that means at 1 centimeter distance from here, 1 centimeter to the right, and there should be 3 centimeters to the left. That is where this uh, center of gravity will be h divided by 4. Okay, this is for a solid cone. Solid means what? It's completely filled. There's no, it's not hollow, basically. Okay. Then they checked for a hollow cone. Hollow means it's empty in the center, like a cone ice cream. Now, for a hollow cone, it's not very heavy on the right side because it's hollow here, right? So then they noticed that the center of gravity is little more towards the center. It is at h divided by 3. You take the whole height and divide it by 3. That's where the center of gravity is. Did you understand what is h divided by 4 and h divided by 3? If this is two lines, here I'm going to divide h with 3. Here I'll divide h with 4. H divided by 3 means you're dividing this line into 3 parts. And this is h divided by 3. Okay. H divided by 4 means what? You're dividing the height into 4 parts. And this point here is h divided by 4. So which is lower? H divided by 3 or h divided by 4? Lower. This is lower. H divided by 3 is little more higher. Right. So for a solid cone, when it is solid, the center of gravity is little more lower to the right. That is h divided by 4. For a hollow cone, which is empty in the center, it's not very heavy at the base. So the center of gravity moves a little bit up. Up means to the left here. That is h divided by 3. Okay, clear everyone? Circular ring. Obviously, the center of gravity will be at the center of the ring. Again, at the center of the ring, is there anything? It's empty, right? That's where this center of gravity is. Next, triangular lamina or scalene triangle. Okay, or any shape, any lamina. Lamina means any random shape. Okay, so they're taking an irregular shape like this. Okay, think of a paper that has no shape. Okay, I will just tear this paper into some irregular shape. Okay, so some irregular shape paper. For this, where will the center of gravity be? Say it's a hard metal sheet. It has a lot of weight. Where will its center of gravity be? You can't find the exact center over here because it has no particular shape. If it was a rectangle, you can find the center. If it's a square, you can find the center. If it's a parallelogram, you can find the center. If it is any regular shape, you can find its center. But if it's any irregular shape like this, can you find the center? Not easily, but there's a way to find it. So how do you find it is you make 3 holes in it. Any 3 random holes. Okay, so here 1 hole, make another hole here, another hole here. Okay, so 3 holes. From those holes, you have to put a stick or something like this, and then you tie a thread down. Let this also freely move. Okay, and you tie a thread straight down, and on the line of the thread, you will draw a line. So what is hanging freely? 2 things are hanging freely. Your lamina is also hanging freely, and the thread is also hanging freely. Both are attracted by the gravity, so they will be at a certain position. On that thread, you will draw a line. You will repeat that same process from all the 3 holes that you have made. Now, all these 3 lines, they'll meet at one point, right? That point is the center of gravity. Is that clear, everyone? This is how the diagram looks in your book. You see, they've drawn 3 of these lines. Yeah. That rope which is hanging straight down is called a plumb line. Have you heard of this word plumb line? If you're doing construction or making a wall, okay, how can you make the wall straight up? You just keep stacking bricks one on top of the other. There are chances that you would make it slanting. And what will happen to the building? The taller you go, the more and more slanted it will get, and your building can fall, right? So the walls have to be perpendicular to the floor. They have to be straight up. How do they make it straight up? Never thought of it? How do they make?
Using plumb line.
They use a plumb line. So what is a plumb line again? It's simply a thread with a weight hanging down. So they attach. Let me see if I have a diagram for it. Plumb line. See, this is how they make the wall. You see the plumb line? So they attach the thread on the top of the wall, and at the bottom of the wall, they can see the line straight coming down. Because when anything is hanging down, they will always be perpendicular to the floor, right? So that way they can make the wall straight. You see that? You get straight walls this way. So what we're doing here is also we're using a plumb line, right? The rope hanging down is a plumb line. What is that?
They see that from a plumb line that the wall shape is correct or not, perpendicular.
Yeah, to make a perpendicular wall to the floor. So the wall is not tilted. Yeah. All right. So you use the plumb line to get those 3 vertical lines. And the point where these 3 lines meet, that is where you get the center of gravity.
So, Anna, for making the Leaning Tower of Pisa, they didn't use a plumb line.
No, they made a proper straight building, but the foundation was weak. So the leaning tower of, I mean, the tower leaned because the foundation was weak. Okay.
Okay.
And it's continuously leaning even now. Okay. So that's why when you build a building, you need to have a strong foundation. Otherwise, that's what will happen. Okay. For a car or a bike, you need to have a low center of gravity. Remember, center of gravity is a point where you can balance that object in any direction. All the weight of the object is felt at that point. So, say for a car, you need to have low center of gravity so that when the car is going fast and turning, it does not tip over. If the center of gravity is too high, then that means the weight of the car is mostly on the top. And if you go fast and you suddenly turn, what will happen? Because of that weight which is so high up, the car can just tilt over. Right? So they need to have low center of gravity. Electric cars, they have very low center of gravity because their weight is mostly in the battery. And where they place the battery? At the bottom. Okay, where your leg is, under the leg, that's where the batteries are. So the center of gravity is very low. They have tried, Tesla, they've tried to see whether the car will tip over, like go in full speed and turn. and they were not able to tip over the car because of its low center of gravity. The normal cars that we use, internal combustion engines, their center of gravity is a little bit higher up. What is the heaviest part on a car? On our cars, normal cars? The engine. Okay. Now, engine is quite high up. If you see where the engine is, in the front it is, and it is a little bit high. It's not very low. Okay. SUVs, they have a higher center of gravity. So they have higher chances of tipping over if you go fast. Okay. All right. Everyone clear about center of gravity? Yes.
Yes.
Okay. The last topic here is about uniform circular motion. Now, when you hear of this word uniform circular motion, what do you understand? Something going round and round at a constant speed. Speed is not increasing, it's not decreasing. It's moving at a constant speed. Right. So we can say uniform circular motion means moving round at a constant speed. Okay. Now, can we say moving at a constant velocity? Oh, that's different. Is speed and velocity the same? No, they're not the same. They're almost the same, but there is a difference. What's the formula for speed? What's the formula for speed?
Distance upon time.
And what's the formula for velocity?
Speed upon distance.
No. Displacement upon time. Okay. What is distance and what is displacement? Are they the same? No. We have seen this before. Okay. If you're traveling from a point A to a point B, okay, we normally don't travel in a straight line, right? The road curves and moves. Like if you're traveling Pune to Mumbai, there are a lot of ghats in the middle and all that, right? So it's not a straight line. This actual path taken is called the distance. Now, what is displacement? Displacement is the shortest distance between A and B. It's a straight line. Okay. So displacement, yeah, it is the shortest distance. Okay. Now, why are they different? Is suppose I'm walking away from A, my displacement will increase. And if I'm walking towards A, what's happening to my displacement? It's decreasing. See, like if I'm walking on this path, the farther I go away from A, displacement increases. But suppose I'm walking on this road, now it's coming closer to A. So what's happening to displacement? It is decreasing. But for distance, it's not like that. As I'm walking on this path, my distance is continuously increasing only. Whether I'm walking left or right or up or down, distance is continuously increasing. But what about displacement? Sometimes it's increasing, sometimes it is decreasing. Same thing can be said even if you're going in a circular direction. Okay, so you start at the point A. Now, as you're moving along the circle, my distance is continuously increasing. If I keep going round and round, what's happening to the total distance? It's increasing. But what's happening to displacement? The farther I go away from A, displacement is increasing. At this point, I'll have maximum displacement. And now as I keep going, what's happening to displacement? It decreases. And if I come back to the starting point, what is my displacement? Zero.
Zero.
So even though I'm going at a constant speed, constant speed, distance increases, but displacement increases, decreases. Understand? So because of that, constant speed is not constant velocity. Constant speed means I'm moving at the same speed, distance is increasing equally. But velocity is increasing and decreasing. The farther I go, velocity increases. Then velocity decreases. Increase, decrease because of displacement. You understand? So uniform circular motion means constant speed, not constant velocity. They can ask you a question. Why is uniform circular motion constant speed but not constant velocity? So you have to mention velocity is not constant because displacement is not constant. There is an increase and a decrease in displacement. Therefore, velocity also will increase and then decrease. Is everyone clear on that?
Because they are directly proportional.
What is, yeah, they're directly proportional, yeah. Okay, the last topic in this chapter is these two words here, centripetal and centrifugal force. If I take a stone and I tie the stone at the end of an elastic rubber band, okay, and I hold one end of the rubber band and I start turning it round and round, okay, the stone is going to go round, right? It's going to take a circular path around my hand and it is going to go round and round. Now the stone wants to go out, it wants to go away. Because see, what if the elastic just breaks in between? What's going to happen to the stone? It's going to go flying in the direction at which it was rotating, right? You understand, everyone? Yeah. So the stone wants to go out, but the elastic is holding the stone in and keeping it in its path, right? So there are two forces acting on the stone. There is the outward force and the inward force.
Centripetal and centrifugal force.
Yeah. So as it's going round and round, this outward force, which wants to throw my stone away, what is that force called?
Centripetal force.
That is centrifugal force. The outward force is centrifugal force. Okay. But the inward force, which is holding the stone to my hand, is that elastic rubber band. That force which holds it together is called the centripetal force. Centripetal or centripetal, whatever. Okay. So these two forces are acting in opposite directions, and that's what holds the stone in position. Now, how can I increase the centrifugal force? The outward force. Huh? Increase the speed, right? The faster I move my hand, the stone is going to go away, right? I'm going to get bigger radius, right? That stone is going to go away. So the faster I rotate, the more centrifugal force I'll have. What if the centrifugal force is too much? The elastic rubber band can just break off, right? Yeah. How can I increase my centripetal force? Use a stronger rubber band. Correct, no? Clear, right? Centripetal force. To increase that force, just use a stronger rubber band that holds the stone in place. Okay. Now, can you think of any other example of something moving like this in a circular direction? Okay, fan is there. But think of the earth revolving around the sun. Okay. So, what is the centripetal force between the earth and the sun? What is holding it closer to the sun? Hmm? To the sun. What is the centripetal force between the earth and the sun? Which holds the earth, pulls the earth towards the sun. The gravity of the sun.
Gravity of the sun.
Yeah, the sun has gravity, and that is what is holding all the planets in place, right? Then why is the earth not falling into the sun?
Because the centripetal force is holding.
Then still the earth will, okay, 1 minute. Then the earth will pull towards the sun and both will go towards each other. And both are having gravity. See, both the gravities of the sun and the earth is the centripetal force, which pulls each other together. My question is, what is the outward force which tries to push the earth away from the sun? Huh?
Centrifugal force.
Yeah, but what causes the centrifugal force is the rotation of the earth. Think of the same stone. What if I stop rotating the stone round and round? What's going to happen? Will the stone still stay in that position like that? No, what will happen to the stone? It'll fall down. It will just fall down. You see, the centrifugal force is created just because of that rotation. If there's no rotation, there is no centrifugal force. You understand? What if the earth went little more faster? See, as of now for earth, it is going at a certain speed that there is equal centripetal and centrifugal force. The inward force and the outward force is equal and opposite. That is why the earth remains in its orbit. What if the earth goes a little more faster, even 0.1 kilometer per hour faster? You know what's going to happen? Same like what happened to the stone when I moved it faster. What happened? The stone started moving away. That's going to happen to the earth. The earth will start moving away from the orbit and it will go away and away and away. And finally, it will leave the sun and it will go into darkness. Okay. What if the earth went slightly slower? than what it is going right now, then it will fall into
Will
the
get
sun.
closer to the sun.
It'll get pulled towards the sun. Okay, so as of now for Earth, the centripetal and centrifugal forces are equal and opposite. In both directions, exactly equal. None of the forces should increase or decrease. Disaster it will be, right? Okay.
And
Now,
then what happened to Pluto?
nothing happened to Pluto. Pluto is exactly the same as it was forever. Okay. It is also having equal centrifugal and centripetal force. It's just that now they realize that Pluto cannot be called a planet. It is still there. It is still rotating, revolving around the sun, but it doesn't have the qualifications to be called a planet. To be a planet, it needs certain, what is this word? Certain specifications to be a planet. See, there are many asteroids also revolving around the sun. Thousands of them. Can we call all of them planets? They are also revolving around the sun. So you just can't call anything that's revolving around the sun as a planet. A planet should have certain properties, like it should be round, spherical, it should be a certain size, it should take a certain number of days to cover the whole sun, it should have its own gravity so that there's no other object around it. Okay, if there's less gravity around an object, then there will be so many objects floating around it. But if it has certain gravity, what it does to all those objects, pulls it everything towards itself. So planets should have certain specifications. Pluto does not have that. Now, 50 years ago or so, when they found out about Pluto, they thought it was a planet. And they said, okay, it's a planet. And that's how we got 9 planets. But just a few years after that, they discovered that Pluto cannot be called a planet because it doesn't meet those required specifications. But then the scientists could not just say that, oh, sorry, Pluto is not a planet. They just left it like that. Okay, until very recently, they realized that, okay, we cannot call Pluto anymore a planet because it does not satisfy any of the conditions. And so they said, okay, finally, that Pluto is not a planet. Okay, but Pluto is still there. Okay, only thing, it cannot be called a planet. Is that clear, everyone? Coming to these two forces, one of these forces is a real force. One of the other force is not a real force. It only exists because of the other force. So which is the real force? Is it the centripetal or the centrifugal? Which is the
Centripetal force.
centripetal force, is the
Centripetal.
real force, the inward force? Because there is a rope, there's an elastic band, there's a rubber band, there's the Earth's gravity and the sun's gravity, which is holding them together. You see, the inward force is the real force. The outward force just exists because that our body is going round and round around it. Okay. So remember, the inward force is a real force. The outward force, centrifugal, is a fictitious force. You know, fiction. What is a fiction? If I tell you the stories of fiction, what does it mean?
Imaginary.
Imaginary, not real. Fiction is a story that someone just made up by themselves. It's not a real story. So fiction means not real. In the same way, centrifugal force is a fictitious force, means it's not a real force. Have you ever felt these two forces, centripetal, centrifugal forces? If you go on a merry-go-round, on the ground also there is that small thing that goes round and round. They sit on it, right? So the centripetal force is what is holding them there. What if you move that thing very fast round and round? What's going to happen to the children standing on it? Huh? They're going to go flying outside, right? Because you're increasing the centrifugal force. And if they're not able to hold on, that means if their centripetal force, which holds them there, if that's not too strong, with their tiny hands, they're not able to hold on, then they will fly. Okay. All right. See, this is the direction at which the object is going to move if the string is broken. See, here is an object P is going around. Okay, around a, this is a merry-go-round. So it's going around this. But suppose the rope breaks right over here. Then which direction is this going to go? It's going to go like this, perpendicular to the rope. You understand? Let me just draw it over here. Suppose this is the rope and the rope breaks over here. Okay, how is this going to go? Is it going to go like that? No. Okay, if it's moving this direction, okay, this is going to go perpendicular to the rope. Okay, that's the direction at which the object is going to go in that path. Okay. Yeah, I think, okay, what is the difference between uniform circular motion and uniform linear motion? Okay. Uniform circular motion is an object moving at a constant speed. Uniform linear motion means in a straight line. So that object is moving at a constant, could be speed or velocity, doesn't matter. Because when you're moving in a straight line, speed and velocity is the same. Only if you're moving not in a straight line, then speed and velocity is different. Okay. So I'll just read this last statement. In uniform linear motion, that means in a straight line, the speed and velocity are constant and acceleration is zero. Acceleration is zero means there is no increase or decrease in speed or no increase in speed. That is, uniform linear motion is an unaccelerated motion. While in a uniform circular motion, what is constant? In a circular motion, what is constant? Speed is constant. Velocity is, the word used here is variable. Variable means it changes. Although speed is uniform. So it is an accelerated motion. What is the formula for acceleration? Anyone knows? Remember the formula for acceleration? Huh? Acceleration is velocity upon time. Change in velocity upon change in time. See, acceleration depends on velocity. So if velocity changes, okay, and velocity depends on what? Displacement. Displacement upon time. So if displacement changes, velocity will change. If velocity changes, acceleration will change. Or in other words, there is an acceleration. Okay. So if a body is moving at a constant speed, but in a circular direction, velocity is not constant, acceleration is not constant. There is a certain velocity change in velocity, and there is a change in acceleration. In other words, it is an accelerated motion. Is everyone clear about uniform linear motion and uniform circular motion? Okay, we're done with this chapter.